In this lecture video, we're going to learn about an important property of a normal distribution, known as the 68, 95, and 99.7 rule. For a normal distribution, the 68, 95, 99.7 rule tells us that 68% of all of the data will be within one standard deviation of the mean. In other words, if we start at the mean and we go up one standard deviation and down one standard deviation, between those two values, we will have 68% of the data. Notice that that leaves 32% left over, which is split between the two tails. In other words, there's 16% left in each of the two tails. This rule also tells us that 95% of the data will be within two standard deviations of the mean. So if we go up two standard deviations from the mean and down to two standard deviations below the mean, then 95% of the data will lie between these two values. This time, that leaves 5% left over to split between the two tails, or 2.5% in each tail. Finally, this rule tells us that 99.7% of all of the data will be within three standard deviations of the mean. So if we take the mean and add 3 standard deviations to it and subtract 3 standard deviations from it, this only leaves 0.3% left over, or 0.15% in each of the tails. Let's summarize the 68, 95, 99.7 rule. 68% of the data fall within one standard deviation above and below the mean. 95% of the data fall within two standard deviations above and below the mean. And 99.7% of the data fall within 3 standard deviations above and below the mean. For example, suppose that 95% of a set of data is between 4.2 ounces and 10.2 ounces. What does that tell us about the mean and the standard deviation? Since we're talking about 95% of the data, we'll use this image to help us. The 68, 95, 99.7 rule tells us that 95% of the data is within two standard deviations of the mean. Labeling these on our normal curve, we have the mean in the center, and 10.2 ounces is 2 standard deviations above the mean, while 4.2 ounces is 2 standard deviations below the mean. Let's consider that first the mean is halfway between 4.2 and 10.2 ounces. To find halfway, we will add them together and divide by 2. This tells us that the mean is 7.2 ounces. Now we can find the standard deviation using either 4.2 or 10.2 ounces. If we consider that 10.2 ounces is equal to the mean plus 2 times the standard deviation, we can fill in 7.2 for the mean and solve for the standard deviation. Subtracting 7.2 from both sides, we have 3.0 is equal to 2 times sigma. And dividing both sides by 2, we find that sigma, or the standard deviation, is equal to 1.5. Now that we know the mean and the standard deviation, let's use that information to find the first and third quartiles. The third quartile can be approximated by adding the standard deviation times 0.675 to the mean. Since we have a mean of 7.2 and a standard deviation of 1.5, we find that the third quartile is approximately equal to 8.2. The first quartile can be approximated by subtracting the standard deviation times 0.675 from the mean. And with a mean of 7.2 and a standard deviation of 1.5, we find that the first quartile is approximately equal to 6.2, or 6.2 ounces. Let's take a look at a different example. In this example, we are given that the standard deviation is 6.1 centimeters and that the 97.5th percentile is 81.5 centimeters. We need to figure out the mean given this information. First, let's label the 97.5th percentile. Here we have P 97.5 is equal to 81.5 centimeters. That means that 97.5% of the data is less than or equal to 81.5 centimeters, and that 2.5% of the data is greater than or equal to 81.5 centimeters. If we were to mirror image this data value to the other side of the curve, we would have another 2.5% of the data in this other tail. In other words, this is P 2.5. With cutting off that left tail, we now have 5% of the data in the tails and only 95% of the data left in the middle. With 95% of the data between these 2 points, let's use the 95 part of the 68-95-99.7 rule. We know that 95% of the data is within 2 standard deviations of the mean. So 81.5 centimeters must be 2 standard deviations above the mean. This allows us to set up an equation. The mean plus 2 times the standard deviation is equal to 81.5 centimeters. And with a standard deviation of 6.1 centimeters, we have that the mean plus 2 times 6.1 centimeters is equal to 81.5 centimeters. And solving this equation for the mean, we find that the mean is equal to 69.3 centimeters. Hopefully you're beginning to see the relationships between the mean, standard deviation, and percentiles. The 68-95-99.7 rule brings them all together. And that concludes this lecture video on the 68-95-99.7 rule.